All right, what questions do you have? All right, let's talk about that. Stop this video, because I'm gonna roll to the next one. If I don't. Come on.
Wait, what?
And I have a hard time drawing like she does, one, clarity wise, and two, I've solved circuits a different way. It's exactly the same way, it's just that I keep a complete circuit rather than having the terminals at top and bottom. But let's still look. Now I'm gonna start with her original circuit, except I'm gonna make one slight modification. And I'll show you that modification before I make it, and then I'll, guess what? Go whiteboard it and calibrate it this morning. Keep saying I'm gonna do that from the get-go. The board drives us all crazy. Let's go ahead and fix it. A lot better when action marks where you tell it. Okay. The only difference I'm gonna make on here, and it'll make it look a little more like what we're used to seeing, is this is R2, right? And it's a 20 ohm. And I'm gonna label this A and B. To get from A to B, I can either go through R2 or I can go through R3 and R4, correct? Or if I touch the screen with my arm over here. It's magic, man. There it is.
Sorry.
So I'll try not to lean on that side of the board. So to get to A to B, I can go through R2 or I can go through R3 and R4. That means R3 and R4 are really in parallel with R2. It looks a little more complex than what our brains are used to seeing. So I'm gonna make some minor modifications that are gonna make that circuit exactly like what we might be used to seeing. So here's R3 and here's R4. No difference. To go from A to B, I can either go through R2 or I can go through R3, then R4. Haven't changed it electrically, I've just redrawn it just a slight bit. So let's go ahead and put in everything we know. No 2 amps was here, that's R1. We'll take away the A and the B just so it doesn't confuse us. I was just doing that to illustrate what we knew a moment ago. R3 is a 10 ohm, R4 is a 10 ohm. And we've got R5, R6. Now, we're going to make another redraw, but I want to go ahead and point out the question you asked. How come we added up to, what was our total resistance? 50 ohms. Well, we ended up finding out the value of this one was what? R1? 20 ohms. I'm going to write it in red because that was one we had to produce. So we had 20, 10, and 10, right? So when we look at those don't change. They're totally in series. Their value doesn't change. But what happens when we have 20 ohms in parallel with what in essence is 20 ohms? You get 10. So let's redraw that circuit, and I'm going to let you see that. And I should have made this much smaller, I'm gonna bring these on the inside. So this is still R3, still 10 ohms. This is still R4, and it's still 10 ohms. Now, the next way I would actually redraw this circuit, if I were doing it, especially brand new to it, is I would come right here. And this is very similar to what she was doing. I just do it a little differently in my teachings. This is still R1. It still has 2 amps. This is still R2. Still 20 ohms. This is R3, R4, and it's 20 ohms. And this is R6, and it's 10 ohms. This is R5, and it's 10 ohms. So all I did was redrew my series circuit there to where I combined my two 10 ohms to make the 20 ohm equivalent for R3 and R4. Everybody with me there? And that's very similar to what she first did. So now, I'm going to take it another step. I'm going to draw R1. Now what is 20 and 20 in parallel? 10, right? So this is still R1, still 2 amps. This is R2, parallel with R3, R4, and it's 10 ohms. This is R5, it's 10 ohms. This is R6, and it's 10 ohms. And that right there is the best explanation to your question that I can give you. If I solve it all the way down to a simple series circuit on this redraw, I've got, we calculated this out to be 20 ohms, and we can see that because we have 20 ohms plus 10 ohms plus 10 ohms plus 10 ohms gives us 50 ohms. I like her charting. It does until you think about you have to, you know, and we'll start with we'll go to a little simpler, probably not a big thing, let's see if we got enough. D, I, R, okay, so let's start with what she had. We knew we had 2 amps through R1. Let's go ahead and label. I got that one R1, R2, R3, R4, R5, R6. I'm just going to have to sketch in an R total down here somewhere. R total, I should say. Alright, so we don't know R1's total yet. We're just going to kind of leave it off. We hadn't really got there yet. We're just robbing from her example, so to speak. We'll go back and talk about how she arrived at each one. Well, we also know that the way this circuit behaves, we got full current here. When it gets this parallel branch, it's going to split. But when it gets here, it's going to reunite, right? So we also know R5 and R6's current. And I don't know her particular reluctance to go ahead and put that in the total while ago, I guess, just to let you see it. But obviously, total current is going to be 2 amps. Now we know R2 is 20 ohms. We know R3 R5, it's 10 ohms. And R6, it's 10 ohms. And we also know total voltage that I didn't write, it's 100 volts, right? Have I got all the givens at this point?
I see where I messed up.
Okay. Well, we're gonna use blue henceforth, since I made the chart red. So, if we know, we know that we've got across R1, let's see, where did we go next? 2 amps, R1, 100 volts. So let's do some voltage drop. What is the voltage drop across R5 and R6? We can go ahead and calculate that, right? 20 volts, right? We also can calculate, what else? Oh, there's part right there. I'm sorry? Let's see, can we calculate total resistance?
We have total volts and total.
Yes, we do, you're right, absolutely right. So we know total volts, we know total current, we know total resistance is what? 50 ohms. The reason for that is we divide the 100 by the 2 amps. Now here's what we know. We know this is part of that 50, this is part of that 50, and in essence, this is part of that 50. So, if this, and this equivalent are 30 ohms, what is R1? How much? 20 ohms. And the reason we know that is because we did our redraws. We know the equivalent of R2, R3, and R4 is 10 ohms, because 20 in parallel with 20, just like we see here, is 10 ohms. So that leaves 20 ohms out of that 50 ohms. So if we subtract 50 minus 10 minus 10 minus 10, that gives us 20. All right, so what is the voltage drop across R1? How much?
40 volts.
Yep, 2 amps times 20 ohms. So if we know we started with 100, we've got 40 here, 20 here, and 20 here. What is our voltage here? If we've got 20 volts here, 20 volts here, and that's a drop, and 40 volts here, what's left? 20 volts. So across here, if we inserted the meter, we'd get 20 volts. So the single voltage drop across R2 is what? 20 volts. So if we know the voltage drop through R2 and we know the resistance of R2, what can we calculate? Current. 20 divided by 20 equals what? 1 amp. So we've got 2 amps of current chucking along through R1. It gets to our split. 1 amp goes this way. What's going this way? 1 amp. Somebody had their Sharpies for breakfast. So how many amps do we have going through R3, and then how many do we have going through R4? 1 amp, right? So if we use our E equals I times R, what are R3 and R4's voltage drops? 10 volts. 1 times 10 is 10 volts. 1 times 10 is 10 volts. Now let's look at the logic behind that for a moment. We started out with 2 amps. We know we got through 2 amps going through here, so we can pretty well pick up on that. If we've got 2 amps going through R1, we know it's going to split at this parallel circuit. It's going to come back. So we were able to get 2 amps for R5 and R6 and our total just by understanding how our circuit works. Well, we also know that some of that's gonna split, but we'll get to that in just a moment. So, so at the point we, did that, we also were able to, once we get to 2 amps, we were able to get total resistance, right? Just by using Ohm's law, 100 volts divided by 2 amps gives us 50 ohms. Well, if we've got 10 here, 10 here, and 10 in this equivalent, because remember, this entire portion right here represents this one resistor right here. So 10, 10, and 10 is 30. If we've got 50, R1 has to be 20 ohms. And if we can get R1's 20 ohms and 2 amps, we can get the voltage drop across R1 just by doing Ohm's law again. We can also get the voltage drop across R5 and R6 because we already had that. 20 plus 20 plus 40 gives us 80. That means we know right here to here, we're going to measure this 20 volts. So we get this. Again, Ohm's law gives us 1 amp coming here. We started with 2 amps, 1 amp splits. 1 amp goes this way, 1 amp goes this way, so we now know 1 amp is here and here. Again, Ohm's law provides us with those last two. So everything adds up. 40 plus 20 is 60, plus 20 plus 20 is 80 and 100. We know our resistances add up because we have 20 ohms plus 10 ohms plus 10 ohms plus 10 ohms gives us the 50 ohms. And our amps add up. 2 amps going in, 1 amp each way on the split, 2 amps coming back. So it proved that. Question?
When you build a chart like that for a combination circuit, the only thing that's actually gonna add up in that chart is gonna be your power. As far as your total equaling.
Just being able to add individual.
Individual.
Now, if it's a series circuit, yeah, everything.
Yeah, I mean, right, but if it's a combination.
Right.
The only way you're gonna have anything in that chart that adds up is if you go on out and do the power.
Unless you do this, unless you look at your redraw.
Right.
If you do it there, then it's gonna add up.
Right.
Resistance, you have to add the resistance of the two before you get the reciprocals, because that's where I messed up. I tried to get 120 plus 110 plus 110.
Right. That, go ahead and solve your series first. And think of it mathematically. This is like the parentheses. Well, this is like the math inside the parentheses, and then this is the parentheses. So what you basically got is 20 ohms. So I meant to write that correctly. Yeah, 20 ohms in parallel with a 10 ohm plus a 10 ohm. So if we go ahead and solve that parenthesis and then do the parallel part, we're spot on. So that's kind of how, if your mind will think of it that way, it'll come out. So let's do a simple one first, and then we'll move into the problems. I'll give you this one to start with. And you're welcome to work it the way Eris does, or this other way. Again, it's just hard for me to change 30-year habits to go to the way she's drawing, and it's good for you guys to potentially see both. And I'll probably give you something wacky that'll work out to be some milliamps and stuff like that. Okay.
You?
I try not to, I really do. All right. And I'm gonna be working that one while y'all are doing it after y'all get it wrote down, so you don't wanna see what I'm doing, just don't look. I don't mean that rude. Sir?
I look over there and I see your answer.
You could. So I'm gonna draw a chart. No, this is R one, this is R two, this is R three. I got one too many spots.
Three point three three amps.
Yeah, I realized just then I screwed up. My bad. Yeah, don't look at mine right now.
Okay.
I'm still. Mine did it directly. You messed up, you trusted me.
Yeah.
See, I'm already jacked up. Jacked it up.
I'll do like her and kind of put it out here. On the sideline.
Okay.
It's still ain't 18. Lord, sorry, y'all. I've got to quit doing this math early on Monday morning.
I did 11.
I know that's right.
Check one more time. Wow.
That's 11, right?
Yeah. I don't know where I'm at. I told y'all not to look up here. I told y'all not to look up here. Woo.
It's,
All right, so total is 11.
15 or 6, plus 10 or 6, or 6.
Okay, that's what we're
I
gonna
had
do.
it right.
Then plus 5.
All right, so let's redraw.
Yeah, but that's what I had to know that they were.
Best y'all up there. It's really hard to do on this big whiteboard. That's my excuse, and I'm sticking to it. It really is. I can do it on pen and paper, because you have to step back to really be able to see everything. So now, we can do some math. If I put the pen down. Now we're back. All right, so I also got that in here. Yeah, don't worry about that last line, that we might use up. All right, so what are we calculating? Here's step back. R one, we have existing, we have current, E is equal to.
Free parking. I'm sorry.
So V is I, R, okay, yeah, okay, I was thinking in my head wrong, so screwed me up. All right, so we know the current through R one is 4.55. So we will say 4.55. So that means to subtract that from 50.
Total for 2 and 3.
I just gotta get.
They do. They do. We're gonna work that together in just a minute. Gotta make more room so we can step back through it. Make sure everything works right. Or VIR, depending on which one you subscribe to. Okay, let's drop back to front for a moment. I'm gonna leave up my messy chart, but I pre-populated with what we know. We've got R1, R2, R3. R1 is a 5 ohm, R2 is a 15 ohm, R3 is a 10 ohm, and we have 50 volts. So look at the chart to the right there. So what we don't know is total resistance yet. So we can go ahead and solve this parallel branch, and if we parallel R2 and R3 together, we get 6 ohms, right? Might not get it the first 2 times, get it the third time. I won't blame on the board. So if we've got a 5 ohm and a 6 ohm in series, we can redraw the circuit like the very last one on the right. So again, it's just like what Ms. Fritz was doing. It's just instead of having a top and a bottom, we just completed the circuit. So now, if we know we have a equivalent series circuit with 50 ohms, 50 volts and 11 ohms, what can we calculate?
Total current.
Total current. We do that by dividing 50 by 11, right? Divided by. And we get 4.545454. So I'm gonna write it as 4.55. And we do know total resistance is 11 ohms, right? And again, we can go back to this draw to see that, but that's the only place, to your point, that would really add up is on this draw, or if we look at our final draw. All right? If we know we've got 4.55 amps, we know we've got 4.55 amps present before and after the split, right? So we know R1's current is 4.55 amps, just by what we know about the way circuits work. So what is the voltage drop across R1? If we multiply 5 ohms times 4.55 amps, we'll come up with 22.75 volts. Now, if this guy is dropping 22.75 volts, what are we seeing across here? 27.25, the difference of the 22.75 from 50, right? So we can come back over here and we could say 22.75 volts. And we could say 27.25 volts. So we know the voltage across R2 and R3 now, right?
Yes.
27.25 volts. 27.25 volts. If we know that, we can calculate current for each one of those, right?
Yes.
So it would be V divided by R, 27.25 divided by 15, which gives us 1.82 amps. And if we do 10 divided by 27.25, or 27.25 divided by 10, that gives us 2.73. What does 1.82 and 2.73 amps add up to? 4.55. So what we're seeing is we had 4.55 amps going through R1 right here. It got to R2, 1.82 went that way, 2.73 went this way. These two added together equate to this, or this, whichever one. And we get the equivalent resistance of these guys, which is 6 ohms, 5 plus 6. Wow, that was kind of messy. Equals the 11. I bet the circle and get the idea. So we arrived at the same results, we just kind of went there a little different way that time. Questions on that one? Let's pull up the ones y'all have been waiting on. You're in your text here. And we'll give you a 10-minute break. I know you're anxious, you've been waiting yet.
Don't have a credit.
We've had some,
Luckily on connection, timeout connections.
yeah, we've had that with a few accounts and they've had to help.
Let's see if they're up there.
Of course they are. That was big. one more file I have to add in when I do the video.
Yeah.
discuss. Let me go ahead and fill in what we know. We know V total or E total is 10 volts. We know R1 is 20 ohms. R2 is 30 ohms. R3 is 50 ohms. And R4 is 20 ohms. Now, if we solve this parallel circuit, if we take the 30 ohms in parallel with the 50 ohms, what do we arrive at? 18.75. You can do either the reciprocal or the product over the sum. But either way, 1500 divided by 80 gives us a value of R2, of this equivalent of R2 and R3 of 18.75 ohms. So if we add the 20, and the equivalent, what do we get for our total? 58.75 ohms. Now, if we use our Ohm's law formula, we can also get I total. So let's do the math. We'll do 10 divided by 58.75, right? Is that right? B divided by R, right? So we get 170 milliamps or 0.17 amps. We'll stay with base units. Be easier to deal with. All right, so what we know here, we go back to this guy. We've got 0.17 amps going this way. And we also know we got 0.17 amps going that way. And somewhere in here, the split, those two should add up to 0.17 amps, right? All right, so if we've got 0.17 amps going through R1, what can we can go ahead and write that in. We can calculate the voltage drop across R1 just by saying V equals I times R, right? 3.4. Yep, we do the same thing. R4 is 20 ohms. We know we got 0.17 amps there. So we've got the exact same thing, right? Oops. Whoa! How'd that happen? If we've got 3.4 volts drop here, that change color, see? What do I know about the 10 volts minus this 3.4 minus this other 3.2, and it's the what we've got dropped across this parallel branch, correct? So R2 is seeing 3.2 volts. R3 is seeing 3.2 volts. So now I can use Ohm's law once again. I can divide 3.2 by 30, and I get what? How much? 0. What? 11 and 666 or what?
Yeah, 10666.
Let's do it. Okay. 3.2. Y'all whispering, I can't hear you. So yeah, 0.11 or 0.10666 continued. All right, so let's do the last one. Do the same thing, 3.2 divided by 50. 0.064. So 0.06. So, move that cursor out of the way. And let's see if everything adds up. We know that we've got 0.17 amps going this way. When it gets to R2 and R3, it splits. And R2 and R3 split should add up to 0.17 amps, does it? Yep. We also know that, we've got 58.75 ohms, and we got that by adding 20, 18.75, and 20. And we also know our voltage drops, 3.4 here, 3.4 here, and our 3.2 across our parallel branch should equal 10, and sure enough, they do. So we only get to add this once, because this is really the same voltage, we can't add it twice. So 3.4 plus one of those 3.2s plus the other 3.4 gives us a total of 10 volts. Very good. There you go. Easy peasy. So again, we know a couple of things there. Whatever current's going through R1 is gonna split and go through R2. We got, once we, find the voltage drop across R1 or the voltage across R2, R3, we, know that those two added together will be about 12 volts. got is just a fairly simple circuit here. We've got 12 volts. I've already populated E total is, or V total is 12. Again, those are interchangeable. R1 is given as 1 ohm, R2 and R3 is 4 ohms and 12 ohms respectively. So I've redrawn the circuit to represent this equivalent of R2 and R3 and then just a total of those three combined at that point. So when we do the product over the sum or do the reciprocal, what do we get for the parallel equivalent of R2 and R3? 3 ohm. And that holds true because we know that it's got to be less than the lowest. So this is 3 ohms equivalent. So what does that tell us our total resistance is? 4. Because if we come up here and we populate this guy with 3 ohms, we simply add the 1 and the 4, 1 and the 3 to get the 4, and we got a 4 ohm. So now that we know total voltage and total resistance, what can we figure? Amps, total current, right? 12 divided by 4 gives us what? So here's what we know. Going back to this circuit, we know we've got 3 amps here. When it gets to this point, it splits, and when it comes back, we don't have a resistor here, but we know there would be 3 amps there. So what can we know R1's current. What can we calculate for R1? Voltage drop, 3 volts, right? 3 amps times 1 ohm gives us 3 volts. If this one is dropping 3 volts,
Hold on, can you go back?
I can.
What number?
All right, let's drop back. Let me undo. Because I want us to understand. Oh, not that much. I just freaked out the PowerPoint.
Wow.
Hey.
I'm sorry.
Oh, it's not your fault. It should work. But what we knew was we had 3 amps. We were able to get our 4 ohms.
Yeah, I got that. I'm just trying to figure out how we get that 3 volts.
I'm gonna see if I can cancel this.
Do I times R?
Please, Lord, let it come back. Yay, it did. All right, now we get to see it again. So that's good.
Yeah.
So we came out and we did our formula here, and we were able to get the parallel equivalent of R2 and R3, which is what? 3 ohms, right? So,
We got the R total, that's 4.
yeah, so this was 3 ohms. And so if we know this is 1 ohm and this is 3 ohms, we got our R equivalent or R total of 4 ohms, right? So we'll go ahead and write that in. Here's 4 ohms. So if we've got R total and E total, V total, whichever you want to call it,
We get amps.
we can get current. Because current is V divided by R, right? So that's 3 amps. Now what that we know is in this type of circuit, when we start, we've got 3 amps of current heading this way. You can't really see it over the writing until it gets to the split, and then some amount's going to go that way, and some amount's going to go this way. But we know we got 3 amps through R1. We don't know what we've got through R2 and R3 yet, but we do know we've got 3 amps through R1 just by virtue of current is the same in a series circuit. So if we've got 3 amps in R1, let's go ahead and populate it. So there's a 3 amps that we know we have because again, total current is 3 amps. That means we have to have 3 amps starting out. Part of it gets here and splits. Part of it goes this way, but when it comes back, when this split comes back, it totals to 3 amps. So 3 amps here. So current trucking along gets right here. Part of it goes this way, part of it goes this way, but then when it recombines, it's 3 amps. So if we've got 3 amps times 1 ohm, what is our voltage drop across R1? 3 volts. If we started with 12 and we dropped 3 here, what do we have across R2 and R3? 9. If we measure here, we're going to measure 9 volts. So we know R2 is seeing 9 volts, R3 is seeing 9 volts. And if we use Ohm's law and divide 9 by 4, what do we get? 2.25 amps. And I can go ahead and predict that this is going to be 0.75 amps, but I can divide divide 9 by 12, and what would I get? 0.75. So, so it makes sense. What we found out is we had total current of 3 amps through R2, 2.25 amps went this way, 0.75 amps went this way. So these two together did indeed add up to our 3 amps that we had down here. If we add the 1 plus 3 plus, yeah, 1 plus 3, I'm trying to add a 4, we don't have a 4. That was freaking me out for a minute, I was looking, used to that extra resistor. If we add our 1 and our 3, we get the 4, which is our equivalent resistance. So it all checks out. I'll try to draw a better circle. How about this? There we go. Almost got one anyway. Okay, and we're on this here. Let's go to the next one. The next one should be easy, but I don't want us to forget how to do these. But this one should be super simple for y'all. Probably before I can even get the table in there, y'all will probably be finished. actually had a real life, story where I was glad I was wearing my brown pants, cause I was beside an 18-wheeler when it blew a tire right beside the car. I thought he'd hit me. Sounded like two 12-gauge shotguns going off right beside me right here.
One guy in the other class was coming up first day, and he was like, "Is he seeing it? Is he not, he's not going?" He said, "My lights are on."
Oh,
But they're supposed to be on.
all right.
At least it was him blowing a tire and not you blowing a tire.
Well, I'd rather been beside him than behind him. I don't know if you've ever seen the Mythbusters where they shoot the tire out. Not a pretty episode.
There's a guy,
I blew a right front one time as I was passing a Cadillac on the interstate, and I almost took out the Cadillac.
It was, our regional manager for the shops back there.
Yeah.
He came by with his laptop and some video. I mean, they got cameras all over the place in every shop and all of it. And they keep telling us don't air up the tires right there in the shop, cause they go out. If we air them up, we have to take them out and put them in the cage.
Yeah.
A couple guys decided they were gonna air up the tire on a Swift truck, and it was, I think it was a spare or whatever, but they was just gonna throw some air in it. It blew, looked like a cannon went off in the guy's face. His hat was still on, but the brim was blowed off, permanently blinded him, deafened him. And because he wasn't doing the right thing as soon as he got out of the hospital, loves to pay for the bill, the hospital bill. Once he got out, he didn't have a job either.
Yeah, they used to have a picture down at the shop, and Daddy used to work there, of a guy inside the cage over pumping a tire that was out.
Yeah, probably the better idea.
He was thinking safety, just had to go backwards. All right, so, this is easy. We know that R1, R2, R3 are all C9 volts. This is a simple parallel, no series. So I pre-populated, R1, R2, and R3's E to be 9 volts or V, whichever you want to say. And of course, total's 9 volts. So, if we get the parallel equivalent of R1, R2, and R3, what did it come out to be? 0.625 K. And I'm gonna stay with K simply because it's gonna make what we're about to do easier. So if I write 0.625 K ohms here, what are my answers gonna come out with on current?
14.4 million.
Yep.
I mean, in what unit, I'm sorry? Milliamps, right? So if I go ahead and do total current, what am I gonna come out with? 14.4 milliamps. So what I know is this. I've got 14.4 milliamps here and here. And the splits are gonna all add up to 14.4, or should, or I didn't do my homework right. So now, if I divide 9 by 10K, or just by 10, that's gonna be in milliamps, right? So that comes out to what? 0.9 milliamps. That's still less than my 14.4. So if I divide 9 by 2, 4.5 milliamps. Still less, even if you add them together. And if I divide 9 by 1, what do I get? 9 milliamps. So if I add 9 and 4.5, I come up with 13.5. If I add 0.9, I come up with 14.4. So these three added together do indeed give me my 14.4. We're dropping 9 volts, which is source voltage, pretty easy. All right, let's do one last one, and then we'll break. And that's going to be a little curveball, mainly because what's wrong with that? Source is on the wrong side. Redraw it with the source on the left, but just make sure your connections are the same. That's your hint. Redraw it with the source on the left. Just make sure your connections are the same. just have to redraw it electrically where if you leave the positive side, you're going through R3, then you, hit a junction, then you have to go to R2 to get back to the negative, then at the other part of the junction, you have to go through R1.
You gotta mirror the whole thing.
Pretty much a mirror image, exactly. You were swinging around based on the supply, you pretty well got something you're used to seeing. Little curveball. So that's what, R1, R2, R3. Fill the table. Oh, what was that? Rats. R2 is 2, R3 is 1, R1 is 4. I'll put it up. Always mind your numbering here, because this is a little opposite of what we sometimes see. got another minute. All right, let's talk about this one. So the emergency calculator up. The calendar, calculator. Okay. I didn't have to redraw this. I could have worked at this original state, but my brain is wired pretty much to see that source on the left and everything else to the right. So all I did was redraw it, and you notice if I'm leaving the positive side, I go to R3. If I'm leaving the positive side, I go to R3. I hit a junction whereby I can go to R2 and get back to the negative, I can go to R2 and get back to the negative, or I can go to R1 and get back to the negative, or I can go to R1. And R1 and R2 are electrically the same on each end, R2 on top, R1 on top, R1 on bottom, R2 on bottom. So that's the equivalent circuit. So I've got to calculate my 4 ohm and my 2 ohm in parallel, which gives me what? 1.33. So 4 ohm and 2 ohm in parallel is 1.33 ohms, right there. So what is my total resistance? So if I add this 1.33, which I've got right here, to this 1, and that's why these redraws can help you so much, is I'm able to see this 1, I'm able to see this equivalent, and I know if I add those two, I'll get my total resistance. So I have a total issue of 2.33 ohms. All right, if I know voltage and I know resistance, what can I get? Current, right? So 7 divided by 2.33 gives me what? 3 amps. So that tells me if I go to this guy, I've got 3 amps coming through R3. It hits the split, and then the combination of the current through that split will equal 3 amps. So let's go ahead and calculate that 3 amps for R3, and this is where you got to be careful because we changed the numbers on you. What is the voltage drop across R3? 3 amps times 1 ohm gives us 3 volts. So we know if we're dropping 3 volts across R3, that leaves what across this parallelogram? 4 volts. So we can go ahead and fill that in. And if we use Ohm's law, and we divide 4 by 4, what do we get? 1 amp. We divide 4 by 2, what do we get? 2 amps and 1 amp equals 3 amps. Then this resistance plus this resistance equals that resistance. All right. Break time. See you at 15 after. I'll go ahead and have the next problem up here. So as you arrive. I don't know if I don't know if the bookstore sells Tylenol. I can't give you any if I had any. But some of your peers can give you some. Yeah, perfect already. It's not gonna do that. See you at 15 after.
Man, show me the money.
See you, sure.
So you're doing it. Up to this. So. Alright, well, you're gonna have a total of 30 volts. So this one's 30 volts. Okay.
That's what's like R three and R four have the design of 30 total.
75, 22.5.
No, R three and R four.
It's only 3 and 4 package.
Yeah, 3 and 4 have the equal 30 volts. Because R two, R two.
Okay.
I like it when your gears grind.
Right.
So R three and R four.
No, that's tires burning.
Yeah, you have to add these to make.
But that's where I get stuck at.
Well, so they-
From the brakes I done put on the
Voltage
motor.
and current for R three and R four.
Absolutely called stupid.
Because,
Alright, explain
alright. R two has 30 volts. Like, you have to have 30 volts coming.
Well, would it R3 and R4 have the same voltage when it's in a parallel?
Or
That's what I thought.
if you got 50 for R one, you got.
I found this on one of those things that he did, one of those websites, they had a chart. and it showed, like,
Have you guys got one problem you're discussing?
So.
Yeah, we're talking about this one.
This one?
Yeah.
Okay, I was gonna say we could go back if we needed to.
So your voltage for your parallel is gonna be equal to R two. Is gonna be parallel to R three. And R three and 4 is series. So you got 30 volts on this side and 30 volts on this side. You got split.
And then you gotta find out from the voltage drops.
Because 50 plus 40 is 90, you take the 90 from 120, you're left with 30. So R two has to be 30, because that's the remaining 30 volts, and to travel through this. And then R three and R four together have to be, because that's the other 30, that's like 30 volts going the other way.
Right, and I also,
And then I get to here, but like,
we'll see your total here is gonna be 2 amps.
yeah, I get that part.
And you got 60 ohms on this side. So 60 divided by 30 gives you 0.5. Alright?
Okay,
So
man.
0.5 amps, you're gonna have 1.5 amps on this side. And since it's a series, they're gonna keep it.
Y'all, I did my
Yeah, okay, I get it.
I never thought out this right, so I was always thinking.
I did my
You got to
You got 5 ohms.
I've got the 0.5 amps for
That was original. I like her, I prefer it, but she redrew it, straight on. Well, see, like in the video, that's the way she did it. She redrew it out straight line.
I think I figured.
Instead of like,
You did get an 8.5 for R2,
Yeah.
30 volts.
Yeah.
Within that repair ratio.
because I got that on.
I basically said that the volt, the amperage for R3 is one add up
They actually did it.
to half one.
The volts, yeah, the volts. Oh, they have it on, that's why they're on the chart going up there.
So now, now
That's why I said, this is why I get this about this study, I'm like, I feel like, okay, don't you have to have
the total. We know that the amp of R3 and R4. Will have to be together.
Well, I said high school. The current is the same. So what does be a 1.5? If 3 or 4 goes to 1.5, and you multiply, it comes out right, like the voltage comes out at 32. Oh. 50 times 1.5, 5 times 1.5. You get 7.5 and 22.5, you get 31. So it actually all works out right.
This is what helps me. This is only one of those, pages that you show us. So I don't do that tonight. Like if it's a series.
How did not?
If I use this,
Just looking at, right now, all I'm looking at is, I'm looking at
see, I don't do mine the way he does. I have to match it. Right, so our three and four are series. Or it's series. Yes.
Everything comes out the way it's supposed to. After I figure out how to get it.
okay.
Yeah, so this is serious. Yeah, and this is your, and this is your. And then when you multiply it, the next one should be 22.
So, this side, you got 30 volts, and you have 60 volts. So you can do your 60, or 30.
Yeah, it's the fact that it was in a series that was throwing me off. I was thinking that they had to add together. Yeah, it was throwing me off. Like a series.
Series, you know,
That was a good one.
That was a
That
good,
was a good
that was a good one. That one makes you think.
That was a really good one.
I got that.
Oh, man. We just looked at the next one after that.
Oh, like y'all having a time too much.
What's that?
I said, y'all look like you're having a time too much. Okay, but you're
They're solving circuit. Some of them are talking about Popeye's chicken.
I'm going back to
Okay, let's go through this. I attempted to do like Miss Friz did in her video, so we can see it really works out to be the same thing. Like it this way? I'll try to stretch myself and do it like this more often. Alright, so what we've got here is this same circuit. If we start at our source, you see we have to go through R1, which is a 25 ohm. We get to a junction, we can go to R2 and get to R5, or we can go through R3 and R4 and get to R5. So that's really that same circuit, and then we have R5 going back to our other side of our source. So what we have is R1, 25 ohms, R2, 60 ohms, R3, which is 5 ohms, R4, which is 15 ohms, and then R5, which is 20. So all I did in the next redraw was add together my two series resistors, a 15 and a 5, gave us 20 ohms. Then on the last one, I haven't solved it yet because I wanted us to do that collectively. But I've got R1, which is 25. We're waiting to get the equivalent of R2, R3, and R4. And then we're going to have R5, which is our 20 ohm. So when we solve down the parallel equivalent of the 60 ohm and the 20 ohm, what do we get? 15 ohms. If we do the parallel equivalent of R2 in parallel with R3 and R4, and we can do product over sum, or we can do reciprocal. It's not going to matter. We're going to get the same answer. But if we do 60 times 20 over 60 plus 20, which is 80, so I'm going to divide it by 80, we get 15 ohms. So we see that that is a valid piece of information. So let's go ahead and write down the equivalent of, well, actually we can't get there yet because it's all in there. It's these two in series in parallel with this guy, right? And that comes out to be 15 ohms. So if we look at the way she did it before, all we had to do is add our 25, our 15, and our 20, right? That gives us what? 60 ohms. Which part did you get? All of it. Okay. Well, remember, we started out, this is exactly the same circuit right here that we're looking at. We've got a 60 in parallel with a series of 15 and 5. So we said we got a 60 in parallel with 20. And we did the math on that. That's what the calculator was. We'll do the reciprocal formula this time. We'll do 60 reciprocal plus 20 reciprocal equals reciprocal. And we come up with the series equivalent of this 60 and 20 in parallel is 15. And now we've got a straight series circuit. So it's just a matter of saying 25 plus 15 plus 20. So your calculator, let's see. So now we know equivalent resistance, we know equivalent voltage. What can we get? Total current, which is 2 amps, right? 120 volts divided by 60 ohms. Now let's look. We've got 2 amps here, and we've got 2 amps here. We can easily see that. We know this is this equivalent that goes all the way back across. But we know for a fact we've got 2 amps here. Now it splits between R2 and R3 and R4. but we've got 2 amps here too. So we can go ahead and add 2 amps to our R1 and our R5 table. So if we've got amperage for R1 and for R5, what can we calculate for both of those? All right, so 25 times 2, 50 volts. And 20 times 2 is 40. All right, so let's look at our meter wise. Across R1, we're dropping. Across R1, I'm dropping 50 volts. Across R5, I'm dropping 40 volts. What am I dropping across this equivalent resistor? I got 50 here,
30 volts.
and 40 here. 50 plus 40 is 90. If I subtract that from my 120, I've got 30 volts across here. So that means I've got 30 volts across R2, and I've got 30 volts across this R3 and R4 in series. So we can go ahead and write 30 volts here, right? Because it's the only one that's seeing the full 30 volts. We've got 30 volts potential across this one, and 30 across these two. Now they're each gonna have some individual values here in a minute, but we're fixing to arrive at it. If I've got 30 volts and 60 ohms, how much current do I have going through R2? 0.5 amps. So what happens is, I've got 2 amps trucking along right here. 0.5 goes through R2. What's going through R3, 4 equivalent? 1.5. So we can go ahead and write that. Now we can do the math and get our voltage drops across R3 and R4. What's 5 times 1.5? 7.5. And 15 times 1.5? 22.5. Now let's talk about where she said check our work. Well, we know R2 had 30 volts across it. So that means the combination of R3 and R4 should have 30 volts. So 22.5 and 7.5 equals what? All right, we know we had 2 amps coming down this guy. We got to R2, we had 1.5 amp, 0.5 amps going through R2, and 1.5 amps going through these guys, and 2 amps coming back down here. And if we add up our total resistances, our 25, our 15, and our 20, and that 15 comes from right there, then we add up to 60 ohms. So check it out. Questions? So easy, you do it in your sleep. There's your one there. Stuff. Well, this is one of the easier ones. But I will go back after this one problem if it's not in there, and we'll do one, just one parallel.
Oh.
Hello. We'll make one up here in a moment, before we get to that last one. Y'all are marking my 5th year anniversary here.
I thought I did too.
No, on an anniversary, I don't have to buy a Here at work. Yeah. They do a paycheck, it's in there, What's that? That's right.
It might be
That is
3
absolutely
and
right.
3. So that's 6, and then you got 1,800.
Yeah, 0.12.
So that
gotten so far is
We know we have the total current of that low
yeah,
end.
I got that,
1 and 2.
yeah. Well, I did, so I got. Since I'm gonna have 3, so I can make it better yet.
So were they all
But that's what I.
or would it be a split
Yeah, I don't know.
between
Yeah.
R1 and R2 together would be that, and R3 and R4?
But I know, one of our 2 is gonna be.
Because it used to be, it would give us 1, and we would have to turn to some.
Just remember, if the Cubs can go to the World Series, y'all can be serious for a little bit.
Because usually it would give us 1 turn, it would be over the body. Anybody got that? I think we all probably got to the same step, and it's just like, yeah.
The voltage drop between, well, the voltage drop across the equivalent of R1 and R2 added to the voltage drop and the equivalent of across R3 and R4. you got going across
So we never know.
the first equivalent, plus whatever you got going across the second.
Yeah, yeah.
So that, that's a parallel
Think about it. You got one in your R1 and R2 equivalent. You got that in R3 and R4, right? Now, once you get that, so your total resistance, then you get your total.
Yeah, I was following along. That was almost cut out.
So, what was your total? What's your total?
it's,
Yeah, half the voltage,
You want to figure the voltage drop across the R1, R2, right? By using that, so what would your equivalent for R2? So you can take that equivalent,
the deed add up
multiply it times,
that's pretty close, yeah, that's
that'll
pretty
give you
close to
full
what
voltage across
we're at.
R1.
Because they're parallel, so you got your total voltage has to be half, but you want your two different. You gotta have half the voltage. Half the voltage for that. No, but you got a total voltage, voltage you add, voltage you gotta add.
Because I see R1 resistance, R1. Now, you have the voltage, you can figure the individual current. So you've got your equivalent R1 and R2, right? And you got your equivalent R3 and R4. You add those together, right? Now you move from R3.
You do like the percentage.
That's the only way I can figure to do it from what we're given. There's maybe another way, but that's all I
But basically,
If I know the current one for this equivalent, I can figure out the voltage for that branch. And I can do the same thing here.
I just don't understand why you.
I don't either, but it comes out when we table this.
If it's a parallel circuit,
But with total voltage, you have to add the voltage of R1.
But you have
Plus
two
the
separate
voltage
current
as equal.
and you have two completely separate parallel circuits. It's not one big.
Yeah, like, we did all that, but it's like when we had separated them, and that's how we got to get it. And then,
I could be completely wrong. I have been all almost like.
but no, like, basically, if we have this, we come out to what you have, like, you come out to pretty much the same thing. But I don't know why we're doing that, but maybe it's because there's two circuits, so each one is really half
Of the total.
of the total voltage.
I think when
That's
you
what
have,
we're going with.
if you have two, if you have two,
I don't guess I would come up to it, but yeah, like I see we did, we were on the right track. Yeah, I understand.
You have to have anything else.
We gotta figure out how to get
I think the two of them, instead of this resistance,
This drop, what's that drop?
that means the voltage should be.
the voltage of R1 and R2. Yeah. You see what we're saying? Like, yeah, R1 and R2 together. Yeah, let's see how.
Round, might be a
We're all in the same.
tenth off.
Yeah, we just got figure out how we do it. Cause your way made sense,
I couldn't figure out another way to do it.
that was pretty cool what we did. Oh yeah, we just kept that to like two separate parts.
So all the students will know what's out.
It'd be like, three, four.
But we'll figure it out.
This one seemed easy, but it was actually harder.
Making my head hurt.
Hey, look, how about that?
Other than, like crack cocaine. Light bulbs coming on. He's got a little round. Seems simple. Oh, that's just a couple of parallels. It's a little more to it. All right, let's talk a minute. Let's talk about properties. Let's talk about what makes this a little more complex, and let's actually work through this circle. We know that we've got a voltage drop across this parallel branch and a voltage drop across this parallel branch. Whatever those voltage drops are should add up to what? 24. So some combination of this plus this should equal 24 volts. Now each one of these is going to have an independent voltage. So therefore, we're going to have some amount of current going through here, some amount of current going through here. And then whatever that total is should be the same as the total for this guy. Now we may have a different amount of current going through R3 and R4 than what we do through R2, and we should because they're different values, but they're going to add up to be the same current that's in this branch. So let's talk about how we simplify this, and again I tried to use her way of solving. So I've got 24 volts coming into R1 going down to the next parallel branch, or R2 going down to the next parallel, then into R3 or R4 coming back to my source. So that's what we've got. So I took and redrew it here. Then I've got the parallel equivalent of R1 and R2 in parallel, and the equivalent of R3 and R4 in parallel. So again, it doesn't matter which formula we use, whether it's reciprocal or whether it's product over sum. I like reciprocal. I'm going to do 100 reciprocal plus 250 reciprocal equals, and I'm going to get the reciprocal of that. And for R1 and R2, I got 71.43 ohms. And I'm going to do the same for R3 and R4, so I'll bring the calculator back up. I'm going to clear it out, and I'm going to do 200 and 250. 200 reciprocal plus 350 reciprocal equals reciprocal. So I got 127.3, or 127.27, since I went 2 decimal places on this guy. So what I did was I took and I got the equivalent resistance for the first parallel branch, and I got the equivalent resistance for the second parallel branch. Now I can just simply add those two to get total resistance. And if I go back to my calculator, because I don't trust my brain on Monday morning, 127.27 plus 71.43, I get 198.7 is my total resistance. 98.7 ohms. So if I drew just a single resistor, that would represent total resistance. Well, if I have total resistance and I have a voltage, what can I get?
Total current.
All right, let's do that. We'll bring up the calculator. I'm gonna divide 24. If I can type it in right. Divided by 198.7. And I'm gonna get 0.12 amps. And I'll stay in amps just to make it easy. So 0.12 amps. Now let's think about this for a minute. We've got 0.12 amps coming down this equivalent circuit. That means we got 0.12 amps. It gets here, it splits, so the sum of these two is going to be 0.12. It recombines, it gets here again, and it splits, and the sum of these two are going to be 0.12 amps. And it's going to be the same 0.12 amps that's up here. It's just splitting in a different manner because we've got different resistive values there. So if we know the equivalent of R1 and R2 is 71.43, and we know the current going through that equivalent, we can calculate the voltage drop that's across here. So let's do that. So we've got, we can for V, which is I times R, so we've got 71.43 times the equivalent of R1, R2, excuse me, that is the equivalent, times 0.12. That gives us 8.57 volts across this equivalent. So I'm going to write 8.57 volts. But I can also write it across R1 and R2, right? Because that's what they're seeing. 8.57 volts. Now I can just do the math and subtract that from 24, or I can do the same thing. I can take that 0.12, and I can multiply it times 127.27, and I get 15.27 volts. That's okay. 15.27. We're rounding, and we expect to have some minor rounding errors, and we'll just see how close that is. So 15.27, 15.27. So now we know the voltage for this branch. We know the resistance. We can get the current, right? And remember, the current for this resistor plus this one should equal total, as should the current for this resistor and this resistor. So let's bring out our calculator again. Let's clear it out. Remember, current is V divided by R, so 8.57 divided by 100 equals 0. And I won't round any. Well, we will. We'll make it 0.086 right there. So now let's do this guy. So we're going to take again V 8.57 divided by 250, and we're going to get 0.034. We're going to go to our last one here. We're going to do the same thing. We're going to take 15.27. We're going to divide it by 350. That's going to equal 0.44. Excuse me, that was 0.044, wasn't it? Yep. Bump the decimal place right there. And last but not least, we're going to do the same thing with 15.27 divided by 200. Oh, it bounced on 15.27 divided by 200. And that equals 0.076. All right, so we said a few things that we should know about are our currents should add up to approximately 1.2. So current between R1 and R2 is 0.086 plus 0.034, 0.2 here. So let's do the same for the next little part. See how close we are? It is, it's gonna be actually dead on too. Cause I went out a couple of the
That's
dust.
all we got done.
Yeah, that's what was stolen, I always thought that it totally.
So again, these two guys added up to the total,
Voltage that.
our voltage, let's see how close we are.
3.84.
And remember, we're talking surrounding areas. If we had 8.57. So 23.84. I'll tell you the same way I used to tell my students. Somebody wanted to give me 24 million and they only gave me 23.84, I would not complain. And I ain't gonna count off if y'all have that. That's just a rounding error. If we carried those out to more decimal places, we'd see that would be exact rather than a little off. Okay, let's work a couple of problems, just some simple ones. Then we'll go back and
I was ready for that.
try to do some more complex ones.
You got some circumception going on, you got parallel with parallel.
We'll start with the basic. Hundred and 8 volts, just because. All right. Good enough. So these are R1, R2, R3. finishing that one before September. I cheated a little bit, I didn't put her first draw, I'll draw that in there and then we'll go. I got a little happy with my draw. And you'll get where you can do these a little easier in your head, but I highly recommend doing these redraws until you do. All right, so I redrew it, kind of like she did in the video. I didn't label R1, but other than that, I almost did perfect. R1 was 9 ohms. So then I realized I have a parallel branch that has an equivalent of R2 and R3. So if I do 15 ohms in parallel with 20 ohms, what do I get? 8.57 ohms. And I've already pre-calculated what we were given. We were given 9 ohms for R1, 15 ohms for R2, 20 ohms for R3, and a total voltage of 108 volts. Now we just arrived at this parallel branch between our 15 and 20 of 8.57 ohms. So what does that make total resistance? 17.57 ohms. So if we know voltage and we know our equivalent resistance, what can we get? Which is 108 divided by 17.57 ohms, which gives us what? 6.15? Going out on a limb, I'm trusting y'all. 6.15 amps. So what we know is we've got 6.15 amps of current going through here. Now, when it does, R1 sees all of that, so we can go ahead and populate R1's current with 6.15 amps. But R2 and R3 have got to add up to that, because when it reaches it here, it's going to split. Part's going to go this way, part's going to go that way. So we can go ahead and calculate voltage for R1, which is what? 55.35. So I'm going to say 55.4. All right, if we know we've got 108 volts and we're dropping 55.4 here, what are we going to have across R2 and R3? 52 point. So yeah, 52.6 if we do the math. And again, I'm rounding. If you didn't round, our answer is going to be, or if you went out 2 decimal points, our answer is going to be very close, just not exact. All right, so now I know that 55 and 52 gives me 107.6 plus 4 gives me 108. So sure enough, these two add up. So I think I'm headed down the right path. So now if I know the voltage across each one of those, what do I have to do to calculate current?
52.6 divided by 15.
So 52.6 divided by 15 is what? 3.51 amps. And I can subtract that, or I can go ahead and do the math. I can take 52.6 divided by 20, what do I get? 2.63. So we got a little rounding. If we add 3.51 and 2.63, 6.14, so we lost a whole 1/100th of an amp doing a round. No big deal. So again, everything we thought holds true, whether it's much more complex or whether it's a simple. Full current is going through this part because there's nowhere to split. We're leaving our source, we're gonna get full current here, and we're gonna have some amount of voltage drop. Whatever we don't drop here, or if we had more resistors over here, we could calculate our branch current, or branch voltage, and that current, when it does get to our branch, is gonna split, and the sum of our two branch currents should equal very close with the rounding error to whatever our applied current is. So, pretty good stuff. I think y'all are starting to get a hang of it. We're gonna keep working some problems, so come back at 11:25, and we'll finish the day out working some more problems. Unless y'all ready to test.
No.
All right, break time.
No, I'm not ready to test on this one. No, there's no one here.
Now, that right there was the
We don't have any.
solid
I don't have any.
circuit, solid circuit.
We'll have to create one
Here. This in
Yeah,
here.
you wouldn't be able to do anything.
We'll pick one.
Two is in series with each other here. It's in series here. It's in parallel with them two. Two parallel, it's in parallel with them two. So you got to redraw. I'm gonna have to redraw that one 4 times before I get down to where I was.
If we even go this way today.
Yeah.
That's not, that's pretty easy.
Oh.
I believe they done that on purpose.
Oh, that's a pretty one. Not me. We're gonna work this one together, and then we're gonna go to that one that everybody's waiting on me to give them a voltage. All right, we'll do what Ms. Fred says. So if I start at my source, what is the very first thing I'm gonna draw after my source? R1, then what? R2, then what? I forgot to put the resistor in there. There's R3, there's R4, they're gonna beat back, then what? R5,
And then R6 and R7.
I'm not gonna label them just yet. Let's go on down here to the next one. So I'll have R1, right? Then I'll have R2, then I'll have R3 and R4 as equivalent, then I'll have R5, then I'll have R6 and R7 as equivalent. So we really got it down to a single circuit, just that quick. So I'm gonna start labeling real quick. So this is R1, this is 10 ohms. This is R2, it's 10 ohms. This is R3, it's 30 ohms. This is R4, it's 60 ohms. This is R5, it's 20 ohms. This is R6, it's 100. Man, I really made it easy on you. This is R7, it's 100 ohms. So, let's go over here and redraw. This is R1, 10 ohms, R2, 10 ohms, R3, comma R4, and we'll get that in a minute. R5 is 20 ohms, and R6, R7 equivalent. And so let's go ahead and do R3 and R4. What is 30 in parallel with 60? 20 ohms. We do product over sum, 30 times 60 is 1800, divided by 90, that gives us 20 ohms here. What is 100 in parallel with 100? 50. We can half it, divide it by 2, or we can say 100 times 100 is 10,000, divided by 200 would give us 50. So either way. So now, we've got, if I rewrite this one a little less, we'll Looks like R210 ohm.
You sure that's the, that is the.
Yeah, turn on the keyboard. So, all I did was I redrew my circuit just like this. I went ahead and solved my two parallel branches, the R3 and R4, the R6 and R7, in parallel with one another. I used a comma, I meant to use the parallel symbol. So there we go. So now I can add up these resistances, can I, to get my R total. 10, 20, 40, 60, 110, right? So resistance total is 110 ohms. So now let's go back and start here. We've got 10 ohms. And I should have put these in. I'll write this one in red. But my blacks were my given. So 10 ohms here, 10 ohms here. R3 is 30. So again, we got our equivalent here of 50. And we had an equivalent here of 20. So 10 plus 10 is 20, plus 20 is 40, plus 20 is 60, plus 50 is 110. If I hadn't added that R2 back, we'd have had a pretty little circuit here. So we started out with 50 volts. So if I got 50 volts and I got 110 ohms, what's my current?
0.45.
Say again?
0.45.
0.45. That's a repeating decimal, right? All right, so that's amps. I'll write a little A in there. All right, so now if I go back to my circuit, what we know is we've got 0.45 amps. I don't know what that little symbol is. I'm going to go back to the pen. Running down this guy. So R1 is not in parallel with anything, so it's seeing the full 0.45 amps, right? How about R2? And last but not least, R5 is 0.45 amps. So we can go ahead and calculate drops across R1, R2, and R5, can we not? All right, so what is our drop across R1? 4.5 volts, right? Same thing on number 2. And number 9 volts. All right, so now what we know is we know the equivalent resistance of these guys, which are 20, which are 50, and we know as a whole they have that, so we can figure a voltage drop across R3 and R4 and R6 and R7. So what is V is I times R, so what is 20 times 0.45? 9 volts. So R3 and R4 are seeing 9 volts. All right, we can do the same thing for R6 and R7. We've got 0.45 times 50. 22.5 volts. So let's see, before we go any further, if everything checks out. We've got to add R1, so I'm going to put a little hash mark there. We've got to add R2. Now R3 and R4 are both seeing the same voltage, so we can only add one of those, right? So we'll mark R3. R5, we got to count it. And R6 and R7 are seeing the same drop, so again, only one of those. So if we do 22.5 plus 9, that's 31.5, plus 9 is 40.5, plus 9 is 49.5. So we're seeing 49.5 out of 50, pretty darn close, being we rounded, especially on this current right here. So now, it's just a matter of filling in the blanks. We can go down to our currents, and we know if we got 0.45, the current between these two branches here should equal that. Same here, they've got to equal that, total current. So what is 9 divided by 30? 0.3 amps. I can almost guess that's probably going to be 0.15. But what is 9 divided by 60? All right. What is 22.5 divided by 100? 0.225. And same thing here. And if I add those together, no surprise, they equal the current total. So not so bad. I'm actually getting the hang of Ms. Fritz's drawings there. I kind of like it. So, let's do the next one, and we'll probably call it pretty close to the day. And let you marinate on some of what you learned. The great thing about this, if you know the rules, you can solve these problems and double check yourself. There's what you're missing. 100 volts. Golly. Or more appropriately.
You know something, man, we won't hear from them. Hey, Karen will be. Kelly can turn it back on this time.
I got the, at least.
Okay. You still have to split it, but you just combine 4 and 5.
No.
Oh, not in the first draw, not in the first draw. They're serious, yeah,
I think everybody's got a copy, so I'm gonna shrink it down a little bit.
So the two, for
That's
R
what
two,
it is.
R two, and R three. And then R four, it adds up to
Okay, yeah.
Y'all from the crew? Y'all from the crew?
No, no.
Oh, we used to have Central in there too.
Yeah, trying to explain to the world, right across the road.
You take the left and bypass it, there's some, once you have to go in the road.
I'm sure like, oh,
There's that, road side in there, and then you can go about the first shop. And the cemetery. The old cemetery by the cemetery.
You talking about microwaves?
cemetery,
Until we lost, we were up by the cemetery.
where?
Straight to my section, double or something.
Yeah, but,
Tennis courts, used to be where the tennis courts were.
Yeah,
This,
yeah,
we got 21.
yeah, I know.
The 21.3.
I got
She was, the school that still standing herself. The one they tore down was, the red have connected together with this, to a cat hall.
so now you
On down
have
the road,
two levels per level.
Yeah.
you know, more for that, those are the elementary school as well. Why would I have to know that? My kids are subscribers to it.
On concrete.
I don't do that. I don't do that. Y'all got a guy out there getting school, go to school.
Cause you don't, yeah, you're pulling through there, right?
Real sorry.
That, yeah.
And that's how you got that.
Then you have to add that to all.
I'm gonna tell you when. You ain't let me finish,
Yeah.
my dream.
Yeah. It's like, yeah, basically you're just adding another step to the same thing. Yeah.
So after that, that one you have to go to.
Yeah, then you calculate your total.
I told you about it, I played it out. When I came, one number, $1 million. I wasn't out there, they came home. The big game.
So that's,
That one number fell, man, that my number 7 fell, third fell, all the way.
we got
Never fell, man, my number. That's a fifth number.
so we got
Current between
Last one,
all of
I was either on one band or two.
Definitely accepted.
yeah,
So that means, that means,
like R two to R six together. Or will it all
The
be?
number fell.
all of, like, every, all
I
of
got,
it.
I'll show you. I took a picture.
So the resistance of
I'll show you the date, you know, like
So
you go
that
back and
means
pull them up.
0.78 goes to that means 0.78.
Show you my class, that's it.
Yeah.
So that's how you can figure out the resistance, I mean, the voltage.
After that, AJ, come in like that.
R two, shit. Like when you add all of them up, they're gonna have to equal 37.
You should.
So
what about that?
Yeah, I got that number, I just, I don't know what's going on. Hold on.
That beautiful wife, beautiful little girl. She's so cute. She look like she's a great ball. 96.
And that means R2 and R3, the voltage of R2 and R3.
Yeah. You know, little Bill.
This is R six, right? We're gonna solve R four and R five parallel, and add R six.
They should
Have
be, that was the voltage of R2 and
I know that's what R two and three.
But with 4 and 5 together plus 6, that's equal to 30. Like, 4 and 5.
My 4, 5, and 6 are. I got 12.47 for 4, 5, and 6. I don't know if that's right.
You got a print copy?
Amen.
I put everything on that one.
I did.
If you travel through 2 and 3, travels through 4, 5, and 6.
Let's work through this one, because we're gonna have 15 minutes. Need to wrap it up. Let me go ahead and tell you, R1 is 80 ohms, right? R2 is 49 ohms.
R4's 37.
Alright, so let's work through the redraw first of all. I redrew it, went through R1, which is my 80. Then I've got my 49 and my 51 carrying me back to the other side of my source. Then I've got my 37 and 45 in parallel, then going through R6 carrying me back to my source. So that's my first redraw there. So I redrew again, and I've got right, virtually the same thing, R1, I've got my 49 and my 51, but I went ahead and I'm about to solve my 37 in parallel to 45. What is that? 20.3. 20.3? So 20.3 ohms. So I went ahead and solved this R4 and 5. Now I've got a parallel, each of them has a series, so I've got to solve the series on each side. So 49 and 51, I need to do that math, it's 100 ohm. R4, 5, and 6, equivalent, come out to be 95.3, right?
Yes.
Out of room, so I can stack that a little bit. So 95.3 in parallel with 100 ohm gives us what?
48.8.
48 point what? 8.8 ohms. So I now know our total is 48.
You still have to
Yeah,
add that.
Thank you. Right, so I got 48.8 that I've got right here. So I've got the 48.8 that I've got to add to the 80, and then I would get my 128. So my R equivalent, I wrote just the value of the last three there. So 128.8. So now, we've got R total. We've got voltage total, so what's our current?
0.78.
0. What?
78.
78?
Yeah.
0.78 amps. So let's look at our draws. We know R1 is seeing that full current, don't we?
Yes.
So let's go ahead and write it. All right, if we know that and we know R1's value, what can we calculate?
The voltage drop.
All right, so what's 0.78 times 80?
62.4.
62.4 volts. So what's happening here is we've got 62.4 volts being dropped by R1. What does that mean across this parallel branch series we have here?
You got 37.
You got 37.6.
37.6 volts from here to here, right?
Yes.
Okay. So if we know that voltage, and we know the equivalent of R2 and 3 is 100 ohm, what's current through that branch? We got 37.6 divided by 100, we can calculate current through here.
0.376.
0.376,
0.376.
so that's going through what?
That's going
So that's going to
R2 and R3, right? 0.376 amps. Now we can do the same thing here. We know that this 37.6 volts is also going through this side here, right? And it's equivalent with 95.3, so we can do the math. 37.6 divided by 95.3.
0.394.
0.394.
0.395.
395. So that's going through, well, actually, that's not going, that's only going through R6, right? Is that right?
No, it ain't going back through R6.
Well, what's happening is, we've got 0.376 going this way, 0.395 going this way, but part of it is splitting in R4 and R5 and reuniting at R6, right?
Right.
So, 4 or 5 have
Do you follow me there, or did I lose you? All right. Because we've got a parallel in here, a while ago when we calculated that current through here, it's going through R2 and R3, right?
Right.
That's 0.376.
Right.
Now, we could do the math, we could subtract that from 0.78, or we could get this equivalent branch right here, and it is equivalent is 95.3, and we can calculate 37.6 divided by 95.3, which gives us what? 0.395, right? So what happens is we've got 0.395 amps of current going that way, right? And we've got 0.376 going this way. R2 and R3 are seeing full current. But when we get to this branch, part of that's going this way and part of that's going that way. We're splitting current, but we're maintaining voltage. Now R6 is seeing that full 0.395. So let's calculate R6's voltage drop, which would be
29.6.
how much?
29.6.
29.63. All right. If this guy was seeing 37.6, this portion up here is dropping 29.63. What is left across R4 and R5?
Unknown number.
37.6 minus 29.63.
7.9.
7.57?
7.9.
97.
7.
0.97 across R4, we can get current, which is volts divided by resistance. So what is 27.97 divided by 37?
It's 0.22.
Point what? 0.22. And because we know the other, we could do subtraction, or we can do the same thing. We can take 7.97 divided by 45. 0.18. So approximately 0.4, which is what this is approximately 0.4. And we can do the math here. Voltage drop 49 times 0.376 amps. 18 what? 0.42. And same with 51 ohms. 19 what? 1.8. 1.8. All right, so let's follow this puppy through and see if it makes sense to us. We had 100 volts. This guy dropped 62.4 right here, and that's what we're saying. So that means this entire network here is seeing 37.6, right? Across here. If we measured with a meter, we would measure 37.6 volts. Now we don't have a single resistor, so we know R2 and R3 should add up to close to 37.6. So let's see if 18.42 plus 19.18 adds up to about 37.6. I think it does, because I get 37, I get dead on 37.6. So that works pretty good. Now we know R4 and R5 are seeing the same voltage, so we only get to pick one. So we'll pick these two that are together, the 7.97 and the 29.63 should add up and do pretty close to 37.6. So we know that part works right. So now we figured current through R1, which was 0.78 amps, right there. So R1 is seeing all of that. And then we calculated through various means the current this way and the current that way. The current through R2 and R3 was 0.376 amps. The current through this other was 0.395. Collectively, those two should add up to very close to 0.78, maybe not dead on. Let's do the math.
Pretty close. You round them up.
So 1, 7, 9, 17. So 0.671 as opposed to, whoa, 771. Oh!
I'm fast over.
Ah, there it went. Yeah, 0.771, I forgot. I didn't carry my off there. So 0.771 as opposed to 0.78, again, close enough. So our circuit checks out when we add this to that, and it also checks out, just froze. But if we add these two, we should get approximately 0.395, which is part of the split. So again, you can make these up on the fly and pretty well check them out and follow the rules. But what we knew here is exactly what we said. We knew that current here is equal to current with these equivalent branches. And I think this one. So anyway, practice some of those. We're going to practice some more tomorrow, and then we'll see how you guys feel. So go home and marinate on this.
In other words, you said we tested them all.
Maybe not that complex. Fun stuff.